Hello, this is my Physics Lab 1 for Physics 2212. My introduction: the purpose of this lab was to determine how much excess charge would be left on a piece of tape, and the physics principles used during this lab are Newton's second law, Coulomb's law, and the gravitational force. The equations I used include F equals K, Q1 times Q2 over R squared, F equals ma, and force of the electron is equal to kq squared over d squared. And the results I got for the lab were that the charge of each piece of tape was approximately 4.43 times 10 to the negative 8th coulombs. For assumptions and models, the each piece of tape was used to model a point charge in order to observe the interactions between the two on a macro scale, and the assumptions made to make this experiment possible were that the long piece of tape was treated as a point charge with the charge concentrated at the center of the tape. Each piece of tape had the same amount of charge evenly distributed throughout the tape, and air resistance is negligible. For the experiment, for my system, it was just tape B and the surroundings. It was tape A and everything else around tape B. The initial conditions were two pieces of tape about 20 centimeters in length and both being neutral charge, and a third piece of tape that acted as the base. And for the details of the experiment, create U-tape by pulling tape off base quickly, and rub plastic pen and hair and hold it near the U-tape to see if there's repulsion between the two. Step 3, create another piece of U-tape via the same method as step 1. And step 4, place one U-tape on top of two books, stabilize it. And for step 5, hold the other U-tape under suspended U-tape and slowly move it up closer to the first initial U-tape until the suspended U-tape begins to float. And then we want to measure the distance between U-tape 1 and U-tape 2. For the expectations, the two pieces of tape should repel each other because they had the same charge. The observations made were that the two pieces of tape did repel each other, and one piece of tape is attracted to neutral objects. And for 7.2 questions, the tape should be attracted to the pen since they have opposite charges. Tape would repel the pen if the tape had negative charge. A neutral piece of tape should be attracted to the pen, and the pen and tape attracted, so the tape has a positive charge. For my experiment results, I measured a separation distance of 0.03 meters. The charge on the tapes was 4.43 times 10 to the negative 8 coulombs. The gravitational force I calculated was 0.01962 newtons. The number of electrons lost by the tape was 2.77 times 10 to the 11th power. And the number of atoms on the tape was 1.02 times 10 to the 18th atoms. And the ratio was approximately 1 electron for every 3.67 times 10 to the 6th power atoms. For the coding part of this portion, I have my constants here. It's just the constants mentioned earlier. And then for my calculation, I just have the gravitational force, which is just the mass of the tape times gravity. And then electric force is set equal to this gravitational force. And then I calculated the charge on one piece of tape to be the square root of the electric force divided by the Coulomb constant times the distance squared. And then we have the electron count being Q over a Q electron, and the atom count being the T length times T width over atom length squared, and the E ratio being atom count divided by electron count. And then we have the objects and spheres here, in the errors and such things. And as we can see in the results right here, the gravitational arrow is in green and the electric force arrow is in orange, and you can see that they're equal force. And the model predicted that the one piece of tape has approximately 1.4 times 10 to the negative 8th power coulombs for the charge, and the deficiency of electrons on one piece of tape to be 8.75 times 10 to the 10th power, and there are 1.16 times 10 to the 7th atoms for every electron on one piece of tape. For the similarities and differences between the model and our experiment, the model uses point charges to predict the charges of the tape, and in actuality, the tapes aren't point charges. The model also assumes that charges on the tape are exactly equal, and this is most likely not true. The model and experiment share similarities in that the result they predicted are almost the same and are only off by a very small percentage. The sources of error are that the measurement of the tape might not have been as accurate as I used the ruler to measure it, and some charge may have been lost in the tape due to me handling it. For the what if question, my observations would stay exactly the same, as even though the charge convention has changed, the charges would still interact the same, and the positive charges would still attract negative charges and like charges would repel each other. And for the Y, it is important to handle the charged tapes as little as possible to ensure that they remain charged, because when they come in contact with my hands and other objects, they may begin to neutralize themselves by gaining back some of the electrons they lost, which would have messed with our experiment results. And that's it.